All right. Can you hear me now? Okay, great. Let me share my screen. All right. Nice. Okay. Guys, it's exciting. It's a privilege to be in this room. I'm Pavel. Thanks, Seb. Thanks, Subarna. Thanks, Kudos Map for organizing this event. It's really exciting. Although it's almost 9. It's before 9 in the morning in Berlin, and I'm a little bit slow. But yeah, it's great to be here. So, guys, like people in this room, you're going to form a future software industry. You start your careers right now, and this is an inflection point between old software and AI native software development, between centralized systems and open ones. You're going to make decisions which are going to define how the next decade looks like. So it's a big responsibility. And also, I really envy you that like you starting your careers right now. Yes, I know that ground is shifting very fast around you. Yes, and like these are turbulent times, no doubt. But I think you're in the good position, and you will win if you will play this right. So let's make this next 20 minutes useful for you. A bit about myself. Wrote the first line of code in the school. It was a small video game. Then got my first PC in 1994 for video games as well. Working in Web2 until 2017, was working with full stack, e-commerce, distributed systems, all kinds. And then in 2017, I fell into the Web3 crypto rabbit hole and never came back. And honestly, I don't want to. I was building mostly in Ethereum ecosystem until 2024 when I discovered Kaspa. And then I co-founded Igra Labs to build Igra network, an EVM-compatible blockchain. So I will get to this into what does it even mean, like what means Ethereum, EVM, blockchain. I think we should define all these terms before going any further. But just so you know, means our blockchain settles on Kaspa block DAC, which you already heard of yesterday. And you can write the same Solidity code as you write for Ethereum. It's just your settlement, your consensus is fully on Kaspa. And Kaspa is the fastest proof of work network in existence. So I was saying, actually, in this talk I will cover like what's so special about Web3, why AI and agentic coding matters, and which skills you need to get ahead of the curve. What do you need to learn? And maybe if time permits, we will do a little demo of Igra network. And also I would love to take your questions in the end. So now let's establish what we've been talking about, because the words like Web3, crypto, and blockchain gets used a little bit loosely. Blockchain is the underlying technology of what we're building. It's a Rails. It's a distributed ledger where transactions are recorded in a way that's very hard to tamper with. Bitcoin is a blockchain. Kaspa is a blockchain. That's the underlying infrastructure of everything we're building. Crypto is an asset layer. Tokens, assets, coins, the financial instruments that live on blockchain, BTC, ETH, CAS. So when your parents ask if you're doing crypto, they mean exactly that. And Web3 is application layer. It's a software built on top of blockchains, smart contracts, DeFi protocols, NFT markets, DAOs. This is where most developers actually work. This is where me and my team works. You write Solidity, you deploy an Ethereum or compatible chain, users interact through wallets. It's programming, but with very different risk assumptions and profile than anything you've normally built before. Yeah, correction, like my team working on intersection of blockchain and Web3. We're building both smart contracts and the underlying infrastructure. That's why it's so exciting, to be honest. So today I'm talking only about Web3, the application layer. And before I get into why AI is extremely important and how it's important, like I want to set up why this domain is different. It's very different from anything else people do in normal software development. So first, immutable deployments. In Web 2, you ship a bug, you just push a hotfix. Maybe you lose some users, maybe you get some bad reviews, but nothing else happens. In Web 3, your code is on chain, and exploits are immediate. Exploits are immediate, deterministic, and in most cases, they're impossible to revert. Machina protocol, one of the new cool decentralized finance protocols, was exploited earlier this year in January for $4 million from the bug, which can be honestly be just one line fix everywhere else. Second, our environment is adversarial by default. Your code is public. Your code is fully public, always. It's on chain. Everyone can read it. Everyone can call any function with any input anytime. In Web 2, you have server, you control access. So it's it's controllable environment. In Web 3, you publish your code, you open your logic to the world, and then you hope it will hold against people whose kind of full-time job is to find problems in your code. Yeah, our industry losing billions of dollars to the exploits. It's improving, but it's still one of the most challenging aspects of our work. Third, test-to-code ratio. In serious Web3 projects, you write like several times more test code than you actually write the production code. Like test-to-code ratio is super high. You do fast testing, you do formal verification, you do invariant testing, like all these are extremely important. Like some teams write 5 lines of tests per every line of Solidity code. So if you come from Web 2 and think, okay, I have some unit test coverage, I have some integration tests, you're not even close. Composability, and that's a tricky one. That's a very subtle one. In Web 3, someone can borrow 50 million, attack your contract, and return the loan all in the same transaction, in the same block even. It all happens in like 10 seconds in the Ethereum world. And money, so no capital actually required to attack your stuff, just code, just logic. It's called a flash loan attack. So your code might be perfect in isolation, but still get exploited because of how it interact, and something like you've never heard of or something never think about happens because you never thought how your code going to work with unexpected external input. And nobody controls the full state. That's very important to understand. And like the last but not most important thing, in Web3, money is your test suit. You're working with real money normally, called liquidity. In Web 2, when your application breaks, again, user complain on Twitter. In Web 3, when your logic breaks, people just take your money. Exploiter take your money quietly. There is no feedback cycle. There is no, oh, we will going to fix it in the next sprint. It's just there. It's immediate. It's binary, exploit or no exploit. So this is the environment. And this is why what I talk about next, I think is very important. So with this environment in mind, I'm going to tell you something which is going to make you and should make you uncomfortable. AI already writes production code. Google, OpenAI, Anthropic, they all did a really great job in developing absolutely new tools which changes the industry as we speak. So it's not a toy project, it's not a demos, it's a real production software. I myself use Cloud Code to write Rust, Solidity. I write infra, test, infrastructure, all this. It's going great. It's good. It's genuinely good. It's fast, tireless. It knows all the patterns. So junior and mid-level coding is being automated right now. Today, and not in 5 years, as you would expect. The normal skill ladder in the industry, which you had before, like junior, mid, senior levels, it's all compressed. So with initial levels being compressed or even disappearing as we speak. Now, for some good news. In most software domains like SaaS, for example, this is enough. And I think SaaS is done. You can see it on the fund market, on the stock market, that SaaS companies are being, like the stock is dropping dramatically because they price in the risks of becoming irrelevant, essentially, because AI for them is enough. AI writes code which mostly write. So you ship it, you got a bug, you write a patch, it's fine, nobody dies. So your company doesn't collapse. So mostly write is perfectly reasonable engineering standard in Web 2. But as you saw before, our environment is very, very different. It's immutable, it's adversarial, your money is your test suit, there is no feedback cycle. So in Web 3, mostly write means that someone drains your contract in your sleep. So the question becomes, if AI writes the code and your environment pushes you constantly, like, and you should be aware of every single exploit possibility which is out there. So what do you actually should you spend time on learning? What should you learn to get ahead of the curve? So why do we even need human in the loop? 3 things. These 3 skills AI cannot replace, and they matter now more than 5 years ago. And you can start building them already today. And they, by the way, not so even specific to the Web3. First, architectural thinking. Read code, understand systems, design for people who are actively trying to break what you build. Second, specifications, spec precision. Define exactly what done means, definition of done, before AI writes even a single line of the code in your project. I mean, AI produces exactly what you told them, what you ask for. If you ask badly, you will get bad results. Garbage in, garbage out. Third, taste and judgment, intuition, the human layer. This is thing you can't prompt into existence. It's just knowing, it's a feeling. You just feel wrong something about something in your code, in your system, before you even can prove it. Let's go through every single one. Architectural thinking. So this is the first skill, because without it, the other 2 doesn't make any sense. So what you can do to develop it? Read more and write less. This might sound controversial to you, but stop trying to get faster in writing code. This race is over. The AI writes code faster than you ever will. So instead, try to practice to read the code as you would read a foreign language, fluently, not translating it line by line, like not going into very small details, but understanding what this code is doing. It's control flow, it's state mutations, it's like side effects, type boundaries, asynchronous patterns. All these things you should see from reading the code, right? So you should be good enough to look at the code, what AI wrote for you, and say, this is wrong, or this will break under the load, or this pattern just doesn't fit here. So you are a reviewer now, you're not the typist. You should develop strong opinions about the code, not master code style. By the way, even before AI, best engineers spent most of their time reading and code reviewing other people's code, not writing their own code. They spend their time understanding systems. Understanding systems they didn't build, because honestly, most of the code is written already. Even like 10 years ago, the software engineering was mostly about composing this, putting pieces together, stitch them together in one system, and knowing when your boundaries between modules, between specific dependencies should be. So when with AI now writing most of the code, the ratio between reading and writing should be like 50-1. So practical advice: spend like 1 hour every week reading some like one smart contract on the Etherscan. On the Etherscan, you can see like most of the smart contracts, they verified. You can see the code. You can understand exactly how they work. It's a beautiful learning environment. So read them, understand them, and this will help you to develop this architectural thinking. And also, like side note, it's also not specific to the Web3, but yeah, try to write less code, not more code. Uniswap, which is like cornerstone of the decentralized finance, that has a swap method, which is like 20 lines long, right? And it moves billions. 20 lines of code moves billions. Then next, permissionless design. This is a Web3 specific concept. This is very specific to Web3 because it also changes how you think about everything. And this was mostly introduced by Ethereum. Vitalik Buterin wrote this like specific definition, walk away test. If you can just drop your systems, if your team will disappear, if a creator of the code disappear, systems still work, it means it is truly permissionless, right? You probably heard about don't trust, verify slogan. So it's not a slogan, it's an engineering principle. It's engineering discipline. In Web2, like the entire security model is trust the server. In Web3, entire security model is trust no one. Or to be more precise, trust the code, trust the cryptography. So if this specific code need an admin to function, if you have centralized servers or elements in your architecture, you just already failed at permissionless design. So you just built Web2 with extra steps. Third, systems and not syntax. There is a CAP theorem, for example: consistency, availability, partition tolerance, right? So in blockchains, it was a specific decision to pick only two, which is consistency and partition tolerance. So this is why your confirmations do not confirm instantly, right? And this design trade-off someone made deliberately. And this is very important. You also make this kind of choices when you design your system. So what do you sacrifice? What do you prioritize? You should have these opinions. AI cannot make these decisions for you. It has some boilerplates. It has some ideas inherited from the previous, from the training data sets, but it doesn't know your specific domain. It doesn't know your specific users. It doesn't know your requirements. So you should be someone who creates these systems. Syntax not that important. System thinking is. So this is all this judgment should happen on the system level, and that's your job. You are the architect, and AI is construction crew, right? So if your blueprint for the house, for the building is terrible, then your building will fall down. Doesn't matter how good and strong the nails are. Next, specification precision, spec. This is the skill. This is a boring skill. People rarely talking about that, but it's not boring. It's actually an entire game right now. So here what I mean: when you tell AI, right, make it secure and fast, it will just make for the specific code. AI will write you something. It will compile. It might even pass all the tests, but secure and fast actually means nothing. It's a very vague definition. So the proper, those are vibes, not specification. Specification have to be precise, and like this is like on the slide you can see like very specific example about performance, like 95% of calls should land within 50 milliseconds. You should have very specific implementation pattern on all external calls, and you should have 100% test coverage for this specific method. Then AI, like this is a specification, and AI know exactly what to do with that, right? So, and you also know exactly how to test what AI do for you. That's also very important, because QA, quality assurance, is also your core skill now. That might sound strange. QA was always the thing engineers didn't want to do. It was the junior part, the very boring part of the job. But now, in AI era, QA becomes the core human contribution to the project. Because AI do exactly what you ask, what you specify. And if your specification and tests are not good enough, then your code will be terrible as well. And if your test, if your instruction is good, then your code will be perfect. So, and here is the Web3 specific insight. Like most of the exploits, most of the Web3 bugs, they're not super dramatic. It's not some super clever attack with multiple servers, with like specific requests or something. It's mostly just 2 lines of code, just in the wrong order. You change the balance after you essentially make a transfer, and it should be the other way around, right? So this kind of bugs is really easy to fetch if you write the right tests and specification, and then AI catches them like that every time. So if you ask AI, make it secure, you will have this bug. If you will ask AI, use exactly this checks and effects interaction patterns, then AI will get it every time right, and you will be fine. Test-driven development, TDD, you might heard about this. Like 10 years ago, it was basically a religion. Like people were talking about like writing tests before code. To be honest, it never worked really well, especially in startup, like really fast-moving environment. But now, these days, it's finally it can shine. So essentially, you write your tests first. It becomes your specification. AI writes the code and then can check exactly what it wrote. So TDD approach, learn it, study it. It's very important today. Like it will get you ahead. It will give you just very strong tools to build better software. AI is just better than humans in writing all this tedious code, in writing all the tests, in writing all this checklist, all different inputs for your code. So just outsource it to it, right? Because you can easily miss some bug or some line when you especially come from lunch and you feel slow, but AI is tireless. It will never miss these things. Again, if you give AI specific instructions on how to write your tests and how to write your code according to these tests. AI is your superpower. Just use it. Now, taste and judgment intuition. That is the hardest one because it's really hard to teach. It's essentially your experience. You can build it only over time. So to give you some examples, this incentive structure will get gamed. So let's say you look at the tokenomics and it looks off to you. You look at the code, it's fine, but then you saw several projects, you saw several similar tokenomic approaches, which were gamed by smart farming rewards, and the whole system was drained. And this is one fits two. Another example, this Oracle would work until someone has 20 million to game it as well. So the code correct, the tests will pass, everything's fine, but then someone with big enough TVL will move the price just enough to exploit your contract to draw all the liquidity from it. So AI cannot properly model tokenomics and take it into the account. You should. The architecture is too clever. Yes, I've seen a lot of teams actually build like mine team included, building like seven levels of abstractions, like very smart code, like only best patterns, like very interesting and composable hooks and all these upgradable models. But then it became so complex, and you cannot even properly reason about it. It's too convoluted. The simpler the better. The less code, the better code. Clever always gets exploited. Social aspect of all this, like, yes, you have all the audits, it all looks good, but then you just don't trust the upgrade pattern. So this is just when some code has multiple owners, so-called multi-sigs, and one of them, for example, belongs to the anonymous founder. And then it means it doesn't matter how smart your code is, it's always can be upgraded, and funds will be withdrawn within 24 hours without you even noticing. So when you have human element in the whole thing, especially about upgrading or changing configuration, and there is no clear process about controlling this upgrade on or change of configuration, then your protocol will be gamed and AI cannot help you. So all this actually all this fell more or less in the same, in the same pattern, right? This is all about experience. You just it's a pattern recognition from experience, essentially. It's something you build up. The senior engineer cannot even prove it when they look at the code, but they just can tell you something is off about this before they actually do a proper code review. So how you develop it? You cannot prompt it into existence. You cannot teach yourself intuition in one day, but you should spend every now and then time reading postmortems. Postmortems in Web3, unfortunately, there are many of them. There are tons of them online. Read them, study them, understand how it happened. There is rect.news, the famous website where most of these postmortems are being published. So just read it and build up, build up your experience, build up your intuition. Yeah, that's essentially how doctors learn, right? Not by reading the books, just by having very bad experience themselves. They learn from doing things wrong, not from doing things right. And then eventually you get there.
You are nearing the end of the time. Just to give you a heads up.
Okay, guys. So just yeah, I actually almost done. So just I don't want to just leave you thinking that AI is your enemy. It's not. It's your best friend now. Like the problem is only if you're using it wrong. Accepted that AI is better at many things. At security checklist, at meticulous following specification, at getting your patterns right. It's all done, especially for writing documentation. Just outsource it. So its work shouldn't be done by humans anyway. So I'm glad that we kind of can outsource it finally and do what we really understand, which is architecture, which is system, which is experience. So it's all about judgment. It's all about you. And I want to leave you with one thing. Every generation of students, they get told, learn X and then you will land a job. And that's not accurate. Like learn Java, learn mobile, learn cloud. I've seen all this. Some of this advice was right, but most of it not, because you're already optimizing for the job which is normally not there. So the AI is already there and it's all automated while you're sitting here. So don't chase writing the code. It's a losing grace. So you need job which is above AI. Then the job which is above AI, be architect, be AI lead, the person in the room with taste, opinions, and judgment. right? And then that's where you want to be. And if you choose Web3 as a domain, just understand it's not a shortcut. It's not a shortcut for the quick money. It's a very like people come thinking it is, but it's wrong. And then just they disappointed and exit when market turns. It's a very hard environment. It's a very hard job, and actually most engineers stay here because they like hard problems, because Web3 has one of the most hardest problems in the industry, and these problems are real. Engineering is real, and if you're good at it, then opportunities are real too. So yeah, thanks for having me. And if we have some minutes, maybe we can have one question or two. And here you can you can scan this QR code and get some references and like things you might look at if you're very interested in deep dive in Web3. Hey Seb, Subarna, do we have any questions?
Yes, Subarna, did you get any question? Thank you, by the way, Pavel.
Hi everyone.
Really insightful. I hope that the students understand it. I recognize a lot that you are saying. And one of the biggest takeaways is that the whole way programming is being done is totally being changed right now. And you indeed really need to mind your skill set and be prepared to be that architect and auditor. Yeah.
I just think that the best thing you guys should do right now, if you didn't already, is you have to invest all you can put into the best model on the market you can afford. It can be Codex, it can be Google Cloud Code, whatever works for you, and then just spend as much time you can with this. You will learn Solidity with this. You will learn patterns. You will learn TDD approach, everything else, cryptography. Just use it. It's just about time. It's like with car. You should have 10,000 hours before you became an experienced driver. It's the same with AI.
Subarna, did you get any questions, by the way? By chance?
All right, guys, you have you probably will circulate my slides, right? So so everyone in the audience will have it. There is my Telegram and X accounts. Please reach out if you want like any word, if you need any advice about this crazy market, crazy industry. I'm happy to help.
Thank you.
Hi Pavel sir. Hello. Hello
Yes,
Pavel
yes.
sir. Are you here?
Yeah, we can hear you.
Sir, I have one.
You broke up, Subarna. Can you please repeat? Let's give him a moment. I will message him.
Yeah, normally it's my connection, which is bad, but
Let me type. Oh, yes, he says he has an internet problem. He's working on it. Anyways, if anybody from the audience wants to ask a question, and I'm not sure if you can unmute yourself, that's also an option. That you just ask the question yourself.
Or you can just drop the question in the chat.
Yeah. Yeah, we will give that a moment, and otherwise I will ask Leo. I think Leo is up next. Let me see. Oh, a moment. Okay, I got a question. Let me see. The question is, when using AI to generate smart contracts, what security mistakes do you see beginners repeat the most?
There's tons of them. One of the most typical is re-entrancy attack. Re-entrance. They just, I already mentioned it in the slides, when you actually make an external call before changing your balances. But there is also that there are way too many. And again, the good news is AI, if you ask it, like that's the deal. If you don't ask it, it won't do it. But if you ask it, please give me all the possible security problems which can happen in Solidity code, it will give you this list. And then you will tell him, okay, now use this list one by one without missing any line to test my code. And then it will find the problems in your code. But then, yes, it's Solidity is one of the most used languages today. So you have like all these instructions. I also have them in this in the addendum. So it's all there. Type checking. Just make sure that your inputs are matching your expectations. Never assume anything about inputs. Like it's always going to be not what you expect. So make sure your smart contract is ready to accept all possible types of inputs. Try not to be mindful, like not make minimal modifications, minimal write modifications in your code. That's essential. Like if you don't have to do this, just reduce this like to several lines. So yeah, that's like most of the Web3 errors is just some as I said, is most like several lines of code, just wrong order of operations inside your code. So this will be all, you can call all this, you can get all this right if you just write tests first, and if you do it like before you write your code, you write all the possible tests for all expected behaviors. That's very important. So this is also it's not related to security directly, but it's kind of obvious that the whole Web3 is essentially cryptography. So before you dive into that, just don't write like any Solidity before you understand the basics of cryptography, like how public and private keys works, like digital signatures, encryption types, elliptic curves, all these things that you understand the derivation part, the derivation path. Like all these things are super important before you actually write a code, because it's not just it's not Web2 when you just write some database interactions or APIs. It's essentially cryptography. So it's it's something you should know.
Thank you, Pavel. Yeah, thank you for this insightful presentation. I'm sure that we also recorded it. It will also be published afterwards. If people want to re-watch it, then it's possible. Because I think presentations like this, it's good to have to watch it several times to really understand what is being said. So that's important. Yeah, then I want to thank you for your time as well. And I'm looking if I can see Subarna back online, and otherwise I will ask Leo to be the next speaker. Subarna will be back in 10 minutes, I see. Let me first ask Pavel, because otherwise you might be able to show a demonstration if Leonardo cannot get the mic, because Subarna is the one who had the how do you say it, the management, the admin power.
Hey, Sam.
Hey,
Sam.
Leonardo.
Can you hear me?
Yes,
Can you hear me?
yes, that's good. And
Nice.
can you also present? Do you also have that option, Leo?
I believe so. Let me try. You guys see the
Yes,
presentation?
very nice. Yeah.
Nice.
Then,
Nice.
Pavel, I want to thank you once again, and I will ask Leo to proceed with his presentation. Okay. Thanks, guys. Leo, thank you. Yes.
All right.
Can you all hear me?
Can you all hear me?
Yes.
Awesome. Thank you so much for having me. Thanks Subarna and thanks Seb for organizing this. It's a pleasure. Hello everyone, I'm Leo. I'm the head of product at Castle. We are building a wallet for the Caspa ecosystem. Today, I'm gonna try to break down in a very simple way how actually crypto wallet works. So if you are like a novice or also if you're an expert, this talk will help you like refresh or know more about